So now what I want to do is I want to take our drawings from the condensed form Lewis structure onto what we call our line angle drawing, okay, which is an abbreviated form. So we are now at number 2. This is the line angle drawing or structure. Okay, so you can imagine how long it takes to draw out some of these molecules, right? We've been drawing really small ones. But imagine if you wanted to draw something out that has 22 carbons in it, hydrogens, oxygens, it would take forever. So this is a shorthand that we're going to use that will make it a lot faster to draw organic compounds. And it works because organic compounds are mostly carbon and hydrogen. So in these, we are not going to explicitly draw out carbons or carbon-hydrogen bonds. So I'm going to write that down. We don't explicitly, there's no E in that, is there? No? Okay. I told you I can't draw or can't write. I can't talk either right now. Nice thing about the iPad, you can just move it back over. Don't explicitly draw carbon or carbon-hydrogen bonds. Another way of saying this is we're not going to show hydrogens that are attached to carbons. Attached to carbons. Okay, so let's look at a molecule. Here's an example. And this molecule is called butane. Okay, and butane in its condensed form is CH3, parentheses, CH2, close parentheses, CH3. Okay, so now the parentheses are on the inside, not on the outside, but on the inside. If we were to draw this out, the parentheses on the inside are going to indicate a chain, which means there's going to be a sequence of them. In this case, there's going to be 2 CH2 groups. So if we were to draw that out, we would have a carbon with 3 hydrogens attached to a carbon with 2 hydrogens attached. I'm drawing this kind of funky for a reason, so let's play along for a second. Then a carbon with 2 hydrogens attached. These are the 2 CH2 groups. And we end up with a carbon with 3 hydrogens attached. As you catch up, I'm going to make that 1 hydrogen a little bit prettier here. So far, so good? Yeah? Okay. So any thoughts on why I drew this in this like zigzaggy pattern as opposed to just straight? Yeah, come on.
Because when you draw like the line angle drawing, each corner represents a carbon.
Nice. So I'm going to translate this to a drawing where I'm not going to show carbons or the hydrogens attached. In this case, that's all of them. So the only way for us to indicate that there's a carbon is if we put a kink in the chain. So the chain is going to mimic this pattern that I'm drawing in right here. So this whole big Lewis structure becomes that simple drawing. And we call this the zigzag. You'll hear it referred to as the zigzag a couple times. Okay, where each vertice of 2 lines and every end of a chain represent a carbon. So each end of a line is where we have a carbon. Good? Another reason why we draw this zigzag pattern is because carbon has 4 bonds attached to it. which means that carbon is a tetrahedron. So I'm going to draw that like this, where we have, going to introduce you to this line, this wedge and dash form, where we have a tetrahedron shape centered around carbon, where two bonds are in the plane. One is pointing out at you, and we show that with a wedge, and one is going away from you, and we show that as a dash. Okay, I'm going to try to zoom over to this other program here for a second. So this is what you're seeing. All right, so here's carbon in a tetrahedron form. Can you see how there's a natural bend to where the bonds are? Okay, so if I were to go back here, and let me change this to carbon. There we go. I want to draw a couple lines on here. 1, 2, 3, 4. So that's butane. Can you see the natural bend? Can you see the zigzag? Okay, so the gray lines here, that is going to be the carbons, the carbon-carbon bonds, and the hydrogens are white. And can you see if we line this up, how some of the hydrogens appear to be coming out at you, and other ones are going away from you? Okay, I'm going to kind of introduce you to the three-dimensional form. Good? It's kind of cool, huh? So we'll play with that a little bit. Okay, so that's our zigzag form. So let's see what time is it? Okay, beautiful. Let's do a couple of examples. Switch back to black here. So here is a problem that will work. So here is the condensed form, CH3, C double bond to O, throwing in that other example, CH2, CH2, OH. Okay. All right. So for a while, you may need to go from the condensed form to the Lewis structure to the line angle, but eventually you're going to be working your way to the line angle form. Okay. So for this one, if we were to draw the Lewis structure, we have a carbon that has 3 hydrogens attached to a carbon as a double bond to an oxygen. Oxygen has its lone pair. That carbon also has a bond to another carbon with 2 hydrogens, which is bound to another carbon with 2 hydrogens, which is bound to an oxygen that has its lone pairs and hydrogen. Okay, I did that really fast. So I would use this as a practice one to go back for. Okay, how many carbons do we have in our chain? 1, 2, 3, 4. So we're gonna have a 4-carbon chain. 1, 2, 3, 4. That last one has an oxygen attached. That has a hydrogen attached. That oxygen has its lone pairs. And I also need to go back and look and see if I forgot anything. I did. I have a double bond to an oxygen on carbon near the end. How do we feel about that one? Sometimes going back and finding which one the double bond to the oxygen goes on can be a little difficult. All right, so a few little notes on this. You will often see, unfortunately, because we're lazy, the lone pairs get left off. Often see the lone pair left out or left off. But do not forget that they're there. Don't forget them. Okay? You may also draw this by not showing, and this is what I think Sadie asked earlier, not explicitly drawing out the OH bond. You can draw this without showing. Ooh, come back. Without showing, come back, come back, come back. Showing the bond. And in that case, it would look like this. OH. And I'll even leave the lone pairs off so you can see what it would look like. And it's because we're lazy and we do it fast, and that's it. So far, so good? All right, let's do another one. Move that one up a little bit. Am I going too fast?
One?
Yeah.
I just have a question. On that one, do you normally draw it as like continuing the chain, or does it matter which direction the OH is like going in the chain? Like if it went up like as the double bond did, is that fine too, or should it continue to like zigzag?
Oh, absolutely. So you could have drawn it like this.
Yeah, I was just wondering if that was
Yeah,
okay.
absolutely.
Okay.
Yeah.